Picture waking up tomorrow morning with a fever. You'd probably reach for some ibuprofen, maybe call your doctor, maybe dramatically text your friends that you're basically dying while sprawled on the couch streaming something. Now picture waking up with that exact same fever 50,000 years ago. No pills, no doctor, no couch, no streaming service. Just you, a cave, some dubious herbs your grandmother swore by, and the very real chance that whatever is burning through your body is going to kill you before the sun goes down. And yet somehow your ancestors made it through. They didn't just survive one plague, one infection, one outbreak. They survived every single one of them, across hundreds of thousands of years, on every continent, in every climate, against every biological nightmare the planet had to offer. Which brings up a genuinely fascinating question. How? How did early humans handle disease when they had absolutely nothing we'd recognize today as medicine? When the most advanced surgical instrument available to them was a sharpened rock? When germ theory sat roughly 50,000 years in the future, still undiscovered? The answer turns out to be simultaneously more brutal, more clever, and more surprising than most people would guess. Before getting into how ancient humans survived disease, it's worth being clear about which diseases they were actually up against, because this is where things get immediately interesting and a little counterintuitive. Most people assume ancient life was one giant cesspool of infection. It wasn't exactly a spa retreat, but the diseases that killed ancient humans were genuinely different from the ones that would go on to devastate later civilizations. Here's the key detail. Early hunter-gatherer groups were small, bands of roughly 20 to 150 people, moving constantly across the landscape. And that simple fact carried enormous consequences for what disease could and couldn't accomplish. Think about how a virus actually spreads. It needs hosts, and it needs fresh bodies to jump into before the previous host either recovers or dies. If your entire social group tops out around 40 people scattered across the wilderness, a highly contagious pathogen runs into a serious logistical problem. It burns through its available hosts too quickly. Everyone either dies or develops immunity, and then the virus has nowhere left to go. It collapses. This is exactly why the catastrophic crowd diseases, smallpox, measles, cholera, plague, weren't major threats during the Paleolithic. They couldn't be. Those diseases require dense, settled populations to sustain themselves. Cities, people packed together, shared water sources, close contact with waste and with domesticated animals. You need agriculture. Hunter-gatherers essentially had the wrong conditions for mass epidemic disease, one of the great unappreciated advantages of their entire lifestyle, even though nobody knew it at the time. What they did face instead were parasites, wound infections, respiratory illness, gastrointestinal pathogens, and a rotating cast of unpleasant conditions we now recognize as things like tuberculosis, salmonella, various fungal infections, and the ever-popular category of something bit me, and now my arm is turning a concerning color. The real challenge wasn't the Black Death. It was constant, grinding, low-level biological warfare from organisms they couldn't see, didn't understand, and had no conceptual framework for even thinking about. And their first line of defense against all of it wasn't medicine. It was behavior. Here's a concept genuinely worth sitting with: behavioral immunity. The idea is simple but surprisingly powerful. Before the immune system even has to fight a pathogen, behavior can prevent that pathogen from ever entering the body at all. Humans, along with plenty of other animals, evolved a suite of automatic behavioral responses functioning as a kind of early warning system. You already experience this constantly without thinking about it. That instinctive revulsion at the smell of rotting food, behavioral immunity. The disgust reaction to something visually contaminated, a festering wound, mold, waste, that suspicious substance in the back of the fridge that used to be food, behavioral immunity again. These aren't culturally learned responses. They're biological. Studies have found that even infants display disgust reactions to pathogen risk cues before receiving any education about disease at all, meaning your brain runs pathogen detection software in the background constantly, and it's been running since before you were born. For ancient humans, this system mattered enormously. Avoiding contaminated water, skipping spoiled meat, instinctively steering clear of visibly sick individuals, handling recently deceased bodies with some level of care or ritual, all of these behaviors, understood consciously or not, reduced disease transmission in real, measurable ways. There's genuinely fascinating archaeological evidence for this too. Deliberate burial shows up remarkably early in the human record. Neanderthals, not even fully modern humans, show real evidence of intentional burial. The exact motivations remain debated. Ritual, emotional, spiritual, some blend of all three, But the practical side effect of not leaving decomposing bodies inside a living space was a significant reduction in pathogen exposure, regardless of intent. Some of the very same burial sites also show evidence of intentional grave positioning and, in certain cases, associated stone tools or ochre pigment, details that continue to fuel debate over exactly how much symbolic meaning versus purely practical hygiene was actually driving the behavior. Ancient humans also moved constantly, and that mattered enormously for basic sanitation. A group that stays put in one place starts accumulating waste. Accumulating waste contaminates local water and food. Contaminated water and food produces gastrointestinal disease, which, in a world without rehydration salts, could easily kill you outright. Mobile hunter gatherers effectively reset their entire sanitation situation every single time they relocated camp. They had no idea why this helped. It simply did. Then there's food preparation, specifically fire. Glorious, civilization building, pathogen annihilating fire. Cooking kills pathogens directly, turning meat that would otherwise carry parasites and bacteria into something dramatically safer to eat. Controlled fire use likely dates back over 1 million years at sites like Wonderwork Cave in South Africa. Though truly habitual, everyday fire use is more confidently dated to roughly 400,000 years ago at sites like Qusem Cave in Israel. A genuinely debated timeline researchers continue to refine as new evidence turns up. The moment ancient humans started consistently cooking their food, they fundamentally changed their relationship with an entire category of foodborne illness. Harvard primatologist Richard Wrangham laid out an influential version of this argument in his book Catching Fire, proposing that cooking was transformative enough not just for disease control, but for digestion and available calories, that it functioned as a genuine driver of human evolution itself. We became different animals, in a real sense, partly because we started applying heat to dinner. Not bad at all for a technology invented by people who genuinely assumed the sun was probably some kind of deity watching over them. Cooking also softened food enough to reduce the sheer amount of chewing required at every single meal, freeing up time and energy that could be redirected elsewhere. One more quiet, compounding advantage layered on top of the direct pathogen killing effect. If any of that has you looking at your own stove differently, stick around, because the immune system side of this story gets even more remarkable. And if you're enjoying this kind of deep dive, go ahead and subscribe now. Behavior gets you pretty far, but pathogens inevitably get through anyway. And when they do, ancient humans relied on something genuinely extraordinary: the immune system. Your immune system can recognize roughly 1 billion distinct molecular shapes. It maintains a working memory of essentially every pathogen it has ever encountered. It distinguishes your own cells from foreign invaders at the molecular level, deploys specialized cells with different tactical roles, some attacking immediately, some gathering intelligence first, some remembering past encounters for decades, some functioning almost like assassins, targeting specifically compromised cells. And it runs continuously and automatically with zero conscious input from you while you scroll through videos and forget to drink enough water. For ancient humans, that same system was doing precisely the same job it does for you, just stress tested against a considerably wider range of environmental challenges from birth, with no safety net whatsoever. That created enormous evolutionary consequences. Individuals whose immune systems responded effectively to the pathogens actually present in their environment survived and reproduced. Those whose immune systems failed generally didn't. Across thousands of generations, this produced populations with genuinely robust immune responses, calibrated specifically to the threats in their own particular environment. There's a striking modern illustration of exactly this principle. When European colonizers arrived in the Americas, they brought pathogens, smallpox, measles, influenza, against which indigenous American populations had no prior exposure and therefore no evolved immunity whatsoever. The resulting death toll was catastrophic, with estimates ranging from 50 to 90% of the pre-contact population dying within roughly a century and a half. This tragedy wasn't evidence of somehow weaker or inferior immune systems. It reflected immune systems that had simply never encountered these specific pathogens before, optimized instead for an entirely different local disease environment built over thousands of years. That same brutal selective logic operated throughout human prehistory generally. The populations that made it through were, in a very real sense, the descendants of people who had already survived whatever diseases existed in their world. Survival, in a very real and biologically measurable sense, was quite literally encoded directly into their DNA, passed down from ancestors who had already run that exact same evolutionary gauntlet and made it through to the other side. Now, for the genuinely surprising part, ancient humans didn't just passively survive disease through behavior and immune response. They actively, deliberately tried to treat illness using plants. That sounds primitive. It genuinely isn't. The pharmacological diversity of plant life on Earth is staggering. Since plants have been locked in ongoing chemical warfare against bacteria, fungi, insects, and herbivores for hundreds of millions of years, evolving an extraordinary arsenal of bioactive compounds capable of killing microbes, reducing inflammation, managing pain, and altering nervous system function along the way. Many modern drugs are either directly derived from plants or synthetic versions of plant compounds. Aspirin traces back to salicylic acid found in willow bark. Morphine and codeine come from the opium poppy. Quinine, still used to treat malaria, comes from cinchona bark, a remedy indigenous Quechua and other Andean peoples were using against fevers for generations before European colonizers adopted it and eventually took most of the credit. Penicillin, technically a fungus rather than a plant, follows the exact same underlying logic: a biological organism producing compounds with genuinely powerful antimicrobial effects. Ancient humans worked out through observation and trial and error, some of it undoubtedly ending badly for specific individuals, which plants in their environment carried useful properties. The evidence for this stretches back remarkably far. At Shanidar Cave in Iraq, a Neanderthal burial site, pollen analysis conducted back in the 1960s by archaeologist Ralph Selecki suggested flowers may have been deliberately placed with a buried body, including species like yarrow and groundsel that carry known medicinal properties. It's worth being upfront that this specific interpretation has drawn real skepticism since then. Some researchers have proposed the pollen could have been introduced later by burrowing rodents, rather than placed deliberately by mourners at all, and the debate over which explanation is correct remains genuinely unresolved. More concrete evidence comes from analysis of ancient dental calculus, the hardened plaque preserved on ancient teeth. Researcher Karen Hardy and colleagues extracted and identified plant compounds directly from Neanderthal remains at El Sidrón Cave in Spain, finding evidence of yarrow, groundsel, and poplar consumption in a specific individual who also showed clear signs of a painful dental abscess. The researchers suggested this particular Neanderthal may have been self-medicating. Sit with that for a moment. Genuinely, a Neanderthal, in real pain from a toothache, roughly 50,000 years ago, possibly and deliberately treating his own discomfort using specific plants he'd already learned actually worked from prior experience. That isn't primitive behavior. That's genuine pharmaceutical reasoning. By the time fully modern humans reach recorded history, plant-based medicine had become sophisticated, systematic, and deeply embedded across virtually every culture on Earth. The Ebers Papyrus, an Egyptian medical text from around 1550 before the Common Era, lists more than 800 medical formulas built from hundreds of distinct plant substances. And modern pharmacologists analyzing many of these formulas have found genuinely active compounds with real therapeutic effects. Traditional Chinese medicine, Ayurvedic medicine, and indigenous healing traditions across every continent all represent thousands of years of accumulated, empirically tested knowledge about which plant does what. The underlying methodology was never a double-blind clinical trial, but the basic process: observe, try, record the result, pass along whatever actually works, is recognizably scientific in its basic underlying structure, even entirely without the formal apparatus, the peer-reviewed journals, or the statistical machinery modern science, eventually built around that same core process. Here's something modern medicine is only recently starting to properly appreciate. Social connection is medicine, not metaphorically, literally. The research here is genuinely striking. Social isolation raises mortality risk by roughly the same magnitude as smoking 15 cigarettes a day. Loneliness is linked to elevated cortisol, impaired immune function, increased inflammation, and measurably worse outcomes across nearly every disease category imaginable. Strong social bonds work the opposite direction, measurably improving immune function, speeding healing, reducing perceived pain, and extending life. Ancient humans lived in tight social groups, not entirely by choice. Survival simply required it. But the side effect of that tight social structure was that sick individuals were rarely left alone. Someone brought food. Someone provided warmth. Someone maintained some baseline level of care. That matters more than it sounds like it should. In a world without IV drips or feeding tubes, the difference between surviving a fever and dying from one could come down to something as simple as whether someone made sure you kept drinking water and eating enough to hold on to your strength. Social care is, in a very literal, biologically measurable sense, a genuine medical intervention in its own right, not merely a pleasant emotional bonus attached to an otherwise separate medical process. Ancient healing practices also embedded illness treatment inside the community in ways that likely produced real physiological effect. Shamanic healing traditions, found in nearly every pre-modern culture on Earth and frequently dismissed today as pure superstition, actually do something modern medicine is still having to rediscover: ritual, expectation, narrative. The deep seated belief that something is genuinely being done to help you. We now call this the placebo effect, and we tend to discuss it dismissively, as though psychologically mediated benefits are somehow less real than any other kind. But the placebo effect produces genuinely measurable physiological changes: real pain relief, real reductions in stress hormones, real effects on immune function. A brain convinced that healing is underway actually facilitates that healing. A shaman performing a ritual surrounded by the whole community, carrying real social expectation and emotional weight, isn't nothing. It's actively activating some of the most powerful internally produced medicine the human body is capable of generating entirely on its own, without a single pill involved anywhere in the process. Everything so far paints a pretty resilient picture, and it should. But there's a genuinely dark chapter in this story, and it begins roughly 10 to 12,000 years ago with agriculture. The shift from hunter-gatherer life to farming often gets framed as unambiguous progress, and in plenty of ways it was, enabling population growth, specialization, eventually cities and civilization. But for individual health, the immediate effects were genuinely brutal. Skeletons from the transition to farming tell a rough story. Average height dropped, a reliable proxy for overall nutritional health. Dental cavities exploded, since a grain-heavy diet is dramatically more sugar-rich than a typical hunter-gatherer diet. Evidence of nutritional deficiencies, anemia, and vitamin shortages visible directly in bone structure increased sharply. And infectious disease? That's when the real epidemics began. Once people settled down, stopped moving, packed into higher population densities, and started keeping domesticated animals in close, constant proximity, everything changed at once. Livestock functioned as a biological bridge for pathogens jumping species. A widely cited 2020 genetics study estimated that measles likely diverged from a related cattle virus called rinderpest somewhere around 2,500 years ago, offering a genuinely specific timeline for exactly when that particular animal to human jump probably occurred. Pigs and birds contributed heavily to various influenza strains. Living in close, enclosed proximity to domesticated animals meant constant zoonotic spillover, disease jumping directly from animals into humans. Meanwhile, stored grain attracted rodents. Concentrated populations contaminated their own water supplies with sewage. Irrigation created ideal mosquito breeding grounds. Trade routes connected once isolated populations, letting pathogens travel farther and faster than ever before. The diseases that would eventually define human history, the plagues, the pandemics, the great epidemic killers, are almost without exception diseases of civilization rather than diseases of raw nature. We created the conditions for them ourselves simply by changing how we lived. It's one of the great ironies of human progress. The same transition that eventually produced writing, cities, science, and modern medicine also created the disease burden modern medicine would spend the next several millennia fighting. Hunter-gatherers, for all their lack of technology, had accidentally been living in a way that minimized epidemic disease, not by choice or understanding, purely as a byproduct of their lifestyle. Agriculture traded that accidental protection for caloric surplus and population growth, and paid for it in a genuine flood of epidemic disease. Here's the part of this story that deserves the most attention. Ancient humans had no germ theory, no microscopes, no vaccines, no antibiotics, not a single pharmaceutical that would meet modern clinical standards. By any formal measure of medical knowledge, they were operating completely in the dark. And yet, they accumulated empirical knowledge about medicinal plants that modern pharmacology is still actively working through today, and still finding genuinely useful compounds inside. Traditional medicine systems around the world have consistently proven meaningfully better than random chance at identifying treatments that actually work. The World Health Organization estimates that roughly 80% of the global population still relies primarily on plant-based traditional medicine, and a meaningful share of the compounds researchers currently investigate for entirely new drugs come directly from following leads inside traditional medical knowledge. Ancient humans developed behavioral patterns without ever understanding the underlying reasons that genuinely reduced disease transmission: avoiding contaminated food and water, burying the dead, staying mobile, cooking with fire. None of it was a scientific intervention in the formal sense. It was practical wisdom accumulated across thousands of generations of direct observation and adaptation. They built social structures that provided exactly the kind of care and connection modern medicine is only now quantifying as genuinely improving health outcomes, something wealthy, individualistic modern societies have largely lost and are currently paying for through epidemic levels of loneliness and the health consequences that come with it. And they carried immune systems, forged under genuine biological adversity, calibrated specifically to the pathogens of their own environment in populations that had already survived whatever that environment could throw at them. None of this is meant to romanticize ancient life. It was genuinely hard. Illness was far more likely to kill you outright. Pain often went without effective relief. Childbirth was genuinely dangerous. Average lifespans were short, though that figure is heavily skewed by high childhood mortality. And ancient adults who actually made it to maturity often lived to what we'd still consider a reasonably old age. Modern medicine is, without exaggeration, extraordinary. Vaccines, antibiotics, surgery, and germ theory together represent genuine, world-altering revolutions in overall human well-being. And it's genuinely worth being grateful to live in an era where a bacterial infection that would have killed a great-great-grandparent now typically gets treated with nothing more than a short course of pills, costing less than a decent lunch downtown. So, how did ancient humans survive disease for hundreds of thousands of years with none of that? Not through luck alone, but through a genuinely layered combination of accumulated wisdom, behavioral adaptation, biological resilience, real social solidarity, and a practical, thoroughly empirical pharmacology built one hard-won observation at a time. They survived because the individuals who didn't were simply no longer around to pass anything forward, and that brutal, iterative, generational process of surviving, adapting, and quietly passing knowledge on is exactly what eventually produced humans capable of discovering germ theory, inventing vaccines, and building medical systems that now let billions of people survive things that would have been near certain death sentences for most of our species' existence. We certainly didn't simply arrive with our current knowledge and our modern hospitals fully formed out of nowhere, ready-made. We were built, slowly and unglamorously, by tens of thousands of years of people doing their absolute best with whatever they actually had. And remarkably, against genuinely brutal odds, most of the time, somehow, it turned out to be enough.